Good morning, students. Well, yesterday we said we were going to start learning how to predict weather using a weather map, right? And that's exactly what we started to do. We began to learn how to tell what kind of front, if any, was coming in using a weather map. Well, today we're going to take that one step farther and learn how to actually interpret some of that information. We talked last week about how a lot of our weather comes from the water cycle in the form of condensation and clouds, right? Well, have you ever wondered how and why clouds actually form? Well, class, it all has to do with colliding air fronts. If you think about what the change in temperature would do to the water molecules in the air, it totally makes sense. Warm air is less dense than cold air. So when they collide in the atmosphere, the warm air rides above the cold air, meaning the cold air rides below the warm air. Now remember what happens as we get higher up in the atmosphere? It gets colder. And what happens when water molecules cool? Think about our demonstration last Monday. They condense and begin to form clouds, which can then create all kinds of crazy weather. Now don't forget about our symbols, class. That top symbol sort of looks like half circles or half ovals. That is a warm front. That second symbol looks like mountaintops or mountain peaks. Remember that mountains are cold, so that equals a cold front. What about that third symbol that kind of looks like a combination of the two? Well, that's exactly what it is. That's called a stationary front, and that's when a warm air front and a cold air front all collide. Now, when they do collide like this, it can create all kinds of crazy weather. This is where storms, clouds, even tornadoes sometimes can occur. Next time you read a weather map in the winter and get excited about a warm front coming in, remember to be careful what you wish for, as that might result in lots of cloudy days, or storms even. Now, not only does this often create lots of rain, these colliding fronts, as the increase in the amount of water in the clouds because of condensation means that they're more likely to precipitate or rain or snow, anything like that. They can also create huge storms, not just precipitation. When the two collide, a ton of energy is created, which basically just means that a ton of electricity is created up there in those clouds. Can you think of something in a storm that kind of resembles electricity? Lightning. So when two differing fronts like this collide, a warm front and a cold front, a thunderstorm is actually often the result. Sometimes, when these storms get really bad, tornadoes and really bad storms can even be the result. Now, class, we're going to combine our knowledge of weather fronts with our graph reading skills. Look at these two graphs below that document a temperature change throughout the course of a day. What if we were asked to determine which one of these days was the most likely to be cloudy? Well, since we can see the temperatures on the left side for all of these, that's what we're going to look at. Let's look at this first one on the left. Well, it looks like every time that temperature was measured throughout the entire day, it stayed the exact same. It was 40 degrees all day long. Now let's look at this one on the right. It looks here like every time the temperature was measured that day, it was a little different. Started off at about 35, then jumped up to about 55, then up to about 65, and then way back down to about 50. So if we're seeing a change in temperature like this, that probably means that a warm front and a cold front are colliding. And the graph to the left probably means that they aren't, because it stayed the same temperature all day long. So we would say that the graph on the right, the one that says Monday, would definitely be the most likely to be cloudy because it shows a change in temperature rather than just a stagnant or the same temperature. Now, class, take just a minute to watch the birth of a tornado. So what happens when two fronts collide at a stationary front?
You guys gotta get in. All right, we're in. Oh, you should while I'm staying with me, boss. Just say it. Okay.
See how it's moving towards the ground? See that streak of lightning? Pretty crazy video, huh? Wow.